All right, guys. So here to finish up the notes from 9.2, which was basically I can graph and really describe a graph in the form ax squared plus bx plus c. Robert, go ahead and put that book away since we're getting started. All right, so we're going to focus on the word problems today. So a couple new things from today will be taking the word problem and writing the equation, and then just analyzing the data that you see on Desmos in context, okay? So before we start, here is basically going to be our outline for these word problems, okay? So I would write this out, and this is how we build our equation, all right? So we'll just call this our outline that we'll use to build our equation, okay? So we'll just say it's going to be h equals negative 16t squared. We've seen that before in some of these word problems, negative 16t squared or negative 16x squared, plus bx plus c. Okay, so we're going to add that new bx term. So if we don't have a bx term, that's more like the acorn falling out of the tree problem. Okay, whereas this one is, you know, kind of starting toward the ground and going higher and then coming back down. Okay, so that's more what this problem is. All right. Anybody want to read 2A for me? Anybody feel like reading? Go ahead, Robert. During halftime of a
basketball game, a screenshot launches features at the crowd. A feature is launched when its initial upward velocity is 72 feet per second. Feature is about 35 feet above the court. How long will it take a feature to reach its maximum height? What is its maximum height? What is the range of functions that models the height of feature over time?
Perfect. Very good. All right. So here is basically how you build your equation. This is the information you need to take from that. Okay. So its initial upward velocity, that's going to be your b value, right? So 72, and you wouldn't have known that. I'm just telling you now. Okay. But that is going to be your b value. So we're going to say b equals 72. All right, and your C value is basically where you start, where the item is shot from. Okay, so you can't really tell from the words on this one. You have to look at the diagram. Okay, so sometimes it's shot, you know, or it starts up from the ground level. Here it starts 5 feet above the ground. Okay, so because of that, we will say that C is equal to 5 because it launches from 5 feet above the ground. Okay, now that I have that, I'm going to go ahead and build my equation by plugging in. So our model then is going to be h equals negative 16t squared. They're all going to start out that way. That's automatic. Plus b is 72, so 72x, and then plus c is 5. So all that's new. It shouldn't seem familiar, right? This is our first example. But now that we know how to use it, if you have your computer open and Desmos open, why don't you work on typing that in? I'll have it on my screen too, so if you want to try to follow along with me. Yes? No, h equals negative 16t squared plus 72. Oh, I wrote 72x. Sorry. Guys, I screwed you up there. I'm just realizing. I threw a third variable in there. This should be the same variable. So let's change that to a t. That's my fault. You don't want to change input variables. My bad. All right, so now that we have that, let me pull up the right graph here. We want 2A. All right, so I have it all kind of right here. Notice a couple things. When I type it into Desmos, I use X and Y instead of H and T. To me, it just seems like Desmos does better with x and y. Okay, so I type it in as negative 16x squared plus 72x plus 5. And then I also, the reason I did y equals 35 there is because that's where we can, so that'll show us on the graph where the fan catches it, 35 feet above the ground. Okay, it said that in the story problem. That's why I did that. Okay. So now we're going to try to start using this to answer questions. So if you have it on Desmos, I would just start clicking around on the parabola and it'll show you some key points, right? So it'll show you 0, 5. It'll show you your vertex is always a big deal, right? That's all that automatically comes up. And then it shows me kind of this last point of intersection, okay, which is 4.035, comma 35, or so, yeah, comma 35. All right, so now let's try to analyze all of that to answer the questions, right? Again, we have the advantage over the other classes because they're not using Desmos, so we should be able to get really exact answers because we have a graphing calculator, right? So let's now let's analyze, okay? So we'll just go question by question. First question is, how long till it reaches its max height? All right, so let's just say it reaches max height after does anybody think they could answer that question? It's in one of the key points on my parabola. Because anybody think they could tell how long it takes for the thing to reach its maximum height? Yeah. It is exactly 2.25 seconds. So if you're talking about maximum or minimums, you need to think vertex in your mind, right? So our vertex, and you might write this out on your note too, or your notes, our vertex, because that's key, is at 2.25, comma 86, right? So our input value is our time value, and our output value is our height value, okay? So it reaches its max height after 2.25 seconds, 2.25 seconds. All right, fair enough. So we keep going. The next question is, what is its maximum height? So its max height is, blurt it out if you know it. How many feet? 86. Very good, right? Our vertex is either our maximum or our minimum. In this case, it's our maximum. It goes 86 feet in the air before it starts to come back down, right? Before gravity takes hold. All right, and then it says, what is the domain? So if we were just using pencil and paper, I would be okay with, or sorry, what's the range? But since we're using a graphing calculator, we're going to do domain and range, okay? We're going to do domain and range. So maybe watch along with me here. All right, so if I asked you what was the domain, what would everybody say? All real numbers, right? So that's true on every parabola that's not a story problem, okay? That's not true here, so we got to think about this problem in context, right? So we talked about this a little bit yesterday, but with story problems, in general, we just look at the first quadrant, right? We look at where seconds are positive and where height is positive. Everything else is kind of not applicable, okay? So our range, or sorry, our domain, that's our side to side, goes from, you know, where we started, which would be 0 seconds, to where we landed, which would be 4.035 seconds, right? That's how long it was in the air. So here's the way we write that out. So we would go 0 is less than or equal to our time, which is less than or equal to 4.035. And all that means is, you know, It took its flight was 4.035 seconds. So very close to 4 seconds, okay? The range is my up and down movement, right? So again, think about the flight of the thing, right? Here's where we start to analyze, start to really think about what we're seeing, right? Remember that I took off from here, okay? I took off from here, and then I go up and up and up and up and up, come back down, and then the fan catches me here, right? So that kind of summarizes the flight. So what is the minimum value of the height off the ground of that whole flight that I just highlighted? What's the lowest y value? Robert?
Would it be y is less, would it be y is greater than or equal?
No, what's the lowest y value? Just what's the lowest y value? All I want is a number, not an inequality. No, that'd be the highest. What's the lowest? So 86 would be our ceiling. What's our floor? Not 34. It goes below 34. Goes below 35, but not a bad thought. What is it? 5, right? Yeah. So it does start right here, okay? So that's going to be my floor, right? So the way we write that in is 5 is less than or equal to the height is less than or equal to 86. So that means that the height of the thing is between 5 and 86 feet, okay? And again, we're getting into the nitty-gritty details only because we are using this graphing calculator. So we should be able to, okay? All right, so we'll do one more together, and that will end our video. So I'm going to give you guys a few minutes on the next one to get ahead of me. Feel free to work with a neighbor if you like. I'll read it, and then I'll kind of start the clock. So you may want to listen before you start talking. All right, so it says, Daniel kicks a soccer ball into the air with an initial upward velocity of 64 feet per second. The ball is 2 foot above the ground when it is kicked. How long will it take the ball? And then it's the same question. How long to reach the max height? How far above the ground does it make it? And then what's the range? We'll do domain and range, okay? So I'm going to give you about 3.5 minutes. So you want to start by filling in your model, right? So writing your equation if you can, based on what we did in the last problem, and filling into our outline, okay? I'm going to go ahead and start the clock. After a few minutes, I'll probably write up the equation just so you're not just sitting there staring if you're stuck. So try to write your equation first, and then you go from there. All right, so just so you at least can type it into Desmos, anybody confident that they know the equation, just the equation, not answers to the questions? Robert, go ahead.
That's the equation. X is negative 6x squared plus 64x plus 2.
That's it, very good. So 64 is what goes as your middle coefficient, and then the 2 is your constant at the end. So if you were able to come up with that, you're on the right track. If not, try to work on typing that into Desmos in the next 51 seconds. Then we'll all look at it together. Okay? What's up, buddy?
What was the range of the example 2A?
We're gonna look at all that stuff together. Oh, the range of the first one.
Yeah, I thought I had it.
It was from 5 to 86. So I'll show it to you. What it looks like. Right there. Robert, you want a Starburst or a Jolly Rancher? Or I got about every color. Just tell me. Just tell me. I'm gonna throw it to you. You can have a purple Jolly Rancher. So, yep.
Thanks.
You're welcome. Thank you for being my lone volunteer today. Help move the class forward. All right, so now let's go ahead and look at this together. So again, I like to use X and Y instead of T and H, just as far as Desmos goes. Okay, I'm going to zoom in a little bit, and now I'm going to click my parabola so I can see those kind of key points. 0, 2, 266, and 4.031, comma 0. Okay, so I'm going to just kind of copy that onto my graph. Just give it a rough kind of copy. And then we'll use our graph to kind of answer the rest of the questions, okay? So I'm going to copy basically those 3 key points as accurately as I can get them onto my graph, and then we'll analyze from our graph, okay? So 0, 2, if I'm counting by tens, that's going to look a lot like 0, 0, so just barely above the ground, right? Then it goes up to 2, 66, that's going to be my vertex. So on my x-axis, I'm counting by 2 or 1s. So I go over 2 and then up like 6.6. So just like right in there. And then it says that I come back down to the ground, which is where h equals 0 at just over 4 seconds. So that's going to look a lot like, I'm going to put it pretty much right on 4, 0. Okay. And now I'm going to trace my guide points. If I want more points, I can go to my table, but that'll give me enough. That gives me my key stuff at least. All right, so not perfect, but, good enough. So I'm going to copy the numbers too, and then I'm going to get rid of my Desmos screen. All right, so now based on what we pulled from Desmos, we'll try to answer all the questions, right? So I will call on you, and you can use you can use what's on your screen or what's on my screen, but we're going to see how you guys are getting at analyzing these graphs, okay? So Blake Toomey, can you answer the first question, which is when does it reach its max height? How many seconds does it take for us to reach our max height? No, don't know. Okay. Max height, minimum height, you got to think vertex, right? So it's something to do with the vertex. Jalen, can you tell me how many seconds it takes us to reach our maximum height? How about Lily B? It's 2 seconds, right? So again, maximum, think vertex, right? So look at that. That's where your eyes need to go, right? So really it should be a, you know, which one is it, 2 or 66, right? So so our first thing is a time. Our second number is a height. On that note, I'm remembering right now that I labeled this graph wrong, so just so we have it right, this is called the h-axis. Let's change that to t and change the t to h. I did that backwards. That was my fault. So it reaches after 2 seconds. All right, and then the next question is, what is its max height? Max height is, Blake, back to you. What is the max height? How many feet? Roofing, help them out. How many feet high does it go in the air? What was it? 60 what? No, not 64. I think you're looking at the right thing, but maybe just seeing it wrong. Kevin? 66 feet. All right, goes up to 66. That's all right. Yeah, you copied it down wrong. I figured that's probably what happened. Yeah. And then domain and range. This part is probably going to be your toughest part. All right, so anybody want to take a shot at the domain if you feel like you really get it pretty well? All right, let me highlight what we're, go ahead.
0 is less than or equal to t, and then t is less than or equal to 4.0.
Very good. Nice job.
Thanks. I looked at these problems before I realized.
That's a good skill. That's a good skill. Yes, sir. All right, so that says our time goes from 0 up to 4.031 seconds, right? So it's like just over 4 seconds, the ball's in the air. Okay, and then the range, anybody want to take a stab at that one? How about I'll put in the symbols for you. So this is automatic. So then we just need our floor and our ceiling. All right, vertically. What's our floor and what's our ceiling? Anybody want to tell me how low does the ball go? What's the lowest the ball ever goes? Not 2, but you're close. 0, right? Because it comes, if we trace the flight of the ball, starts at 2, goes up and up and up, then it comes down, 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 and finally gets to 0. So it does go to 0 at some point. What's my ceiling? Grant? 66. That's right. Yes. Yeah. All right. I'm going to go ahead and stop the recording there. Then we'll take a break. Why don't we take like a 3-minute break where we get up, move around for a minute, and then we'll finish with a little minor exit ticket. I'm going to end the recording and then start your 3-minute break timer.